Hi, today we will be doing different codes based on which we will notice the behavior of the microcontroller. The microcontroller that we are going to use is Arduino Mega 2560. So this ATmega 2560 is programmed in the source code. The source code option is available here. You can click here or you can go in the edit properties section and you can click edit firmware. So that will also open the main code. In order to compile the main code, you will first go here, build project. Once the project is built, since I have already done it, once the project is built, you need to upload the hex file. For uploading the hex file, go into the edit properties, click here, and wherever you have saved the hex file, I have saved it on the desktop. So this is the first file 7.1 example, which I am going to upload. This is how I generated the hex file. Now after uploading the hex file, I will turn on the simulation button and this will turn on the simulation. Now let's see what the source code is saying. So we are going to write an AVR program that will send output to port B. So we are going to set port B of this microcontroller as output. We are taking a character in order to store the loop that we are going to run. DDRB is taken as output. How do we know that it is taken as output? We are going to take FF, which means setting both of the 8 bits, 4 bits and 4 bits combination on 1 or maximum, which means it is taken as output. This is a loop. This is how long the loop will run and the LEDs will remain on. Now, this was the first code, and here is the port B 0, 1, 2, 3. So these are connected as output of LEDs. Moving on to the next code, which is 7.2. Let's first see the code and then we will see the simulation. In this example, we are going to program to send hex values for ASCII characters 0, 1, 2, 3, 4, 5, A, B, C, D to port B. Now again, we are taking port B as output. You can see they have set it on XFF, 0FF basically. And they are storing the characters that they need to display. For the loop, then they are taking a character. So this list is basically matrix, or you can say an array. This loop runs and the array runs. So like first 0 will be displayed, then 1, 2, 3, 4, 5, 6, 7, 8, 5, A, B, C, D. You can run it in two ways. Either you can use LED sequence, 8 LEDs, or you can use the 7 segment LED. So here I have used LEDs instead of 7 segment. I will upload the code, the hex file 7.2, although it is already uploaded, but we can do it again as well. Click OK and then run it. So you see the LEDs have changed on the basis of the code that we have done. Now moving on to the next code 7.3. Write an AVR program to toggle all the bits 200 times. So for this much time, we need to change the output on B 0 and 1, 0 and 1. So like even LEDs will turn on while the odd LEDs are off, and then it will alter like one LEDs will turn odd LEDs will turn on and even LEDs will turn off. Again, we have said DDR port B as output. Port B is also taken as input because it's needed to be reverted. Like this sequence need to be turned into 0101 as well. And then this is a loop that it needs to run for 200 times, and after that it will stop. Now let's check the behavior here. As I said, using the source code, I already generated the hex file. I am going to upload the hex file and then we will notice the behavior. It's 7.3. Click OK and start the simulation. So you can see these lights turned off and only the other ones are on, as they had mentioned in the sequence. This is the input. The input is reverted 0101 sequence, and that is why 01010101 sequence is shown. Moving on to the fourth code, which is 7.9. Now let's see what is written in the source code. 7.9. Okay. Now this is the source code 7.9. LEDs are connected to port B. Obviously, LEDs will turn on only if port B is giving output. Write a code that shows the count from 0 to FF. H means hex. So basically 0 to 15. And you can see all zeros, all ones on the LED. So let's now upload the hex file. This is the hex file that we are going to take, 7.9. Click OK and start the simulation. So you can see now all the LEDs have turned on, just like they said, from this to this. Okay, let's move on to the next one. Next we have is 7.11. Let's read the behavior of 7.11 code. Write a program to get a byte of data from port C. So you are getting data from port C, like port C is basically input. If it is less than 100, send it to port B, otherwise port D. So if it is less than 100, port B will show the output. If it is more than 100, then it will be sent to the port D. Now this behavior is shown in the code as well. Let's upload the hex file first. This is the hex file 7.11. Start the simulation. Now these switch are will basically show the behavior. Now based on if the output is more than 100, this will lit. Otherwise, only one of the segment will turn on, or only one port will show output. Okay, next code is 7.12. In 7.12, you need to run program on your simulator and you need to examine the results. So just like we said, FF is output, so B, C, D are outputs, and they are performing different operations. AND operation, OR operation. In AND operation, if we have zero, if anywhere we have zero, the answer is zero. Like 350F, so this bit will always remain zero. Then 0468, so this bit will remain zero. And then on C we are using AND operation. In AND operation, if we have zeros on both sides, then we have zero. In XOR operation, the similar ones are basically showing zero. However, 01 or 10 sequence is showing one or output. And this is the inverting operation. If there is zero, it means it is one. So this is what we are going to see on the Proteus as well. Let's upload the code. So here we go. Now, on basis of what values they are showing this, if you see the code, we have taken 350F, 0468, 5478. If you will open the bits, Just like we know for F, it is 1, 1, 1, 1, 4 ones. And then for the other F, it is 4 ones. Similarly, open the bits and perform the operations. You will notice that this is how it appears in the order. Okay. Next code. Okay, this is 717. So moving on to 717. Write a program to read pin 1 and 0 of port B, issue an ASCII character to port D according to the following table. So if it is 0, 0, port 0 will turn on. If it is 0, 1, 1 will be sent to port B. If it is 1, 0, 2 will be sent to port D. And if it is 1, 1, 3 will be sent to port D. So port B is basically set as an input and port D is taken as output. Now, what input will go into port B? We are taking port B, and this is the register that will ring, or you can say this is the pin which will be read. And what will be stored or read in the port B? This sequence. Zero is just zero is just a number. B stands for bit, which means there are 8 bits. So if you see 4 bits and 4 bits. So according to the case, first is 0, 1, 2, 3. Each ASCII will be displayed 0, 1, 2, 3 ASCII. Now let's check it using the Proteus input. Edit properties. Let's upload the code 7.17. Okay, start it. Based on the input, the output will be decided. You can see the output changes based on the given input. Next we have is 7.24. 182324. Okay, this is 24. Set bit 5 of port B to on and bit 7 of port C continuously. So B is set as an input, C is set as output. And they're showing that over the time the status changes, or it set bit 7 of port C to 1 and bit 7 of port C to 0 based on the given conditions. If it is shifting from 5 to 1, then set it to bit 7, and otherwise if it is not moving from 5 to 1, shift it to 0. Let's check the behavior in the code. Which port? Bit 7. Okay, from bit 5 output is taken on bit 7. So bit 5 is 0, 1, 2, 3, 4, 5. See, on bit 5 input is given, and on bit 7 input is taken, output is taken. Okay, let's move on to the next code, 25. A door sensor is connected to port B at pin 1. LED is connected to port C at pin 7. Now program it to monitor the door sensor. When it opens, turn on the LED. So 25, we need to take port B pin 1 and port C pin 7. This is 25. Let's upload the code. The code is uploaded using the hex file. Hex file is 25. Okay. Turn on the code. We said that pin 1, this is pin 0, this is pin 1, and we need to take output on pin 7. Next code is 26. In 26, we are saying that a program to pack BCDs 0 to 9. 29 is basically the sequence of 8 bits to ASCII and display the bits on port B and C. So Depending on the solution of this, the outputs will be displayed on port B and C. Let's upload the hex file of 0.7.26. Click OK, start it. And you can see based on the input that we had given, it is showing output on both of the bits. Next is 27. Convert ASCII digit 4 and 7 to packed BCD and display them on port B. Now what they are doing is that they want you to pack them, to convert them into 0F sequence. Unpack is basically 4 zeros and 4 ones for 0F, and packed is converting 4 zeros and 4 ones into 0F. So that is packed. Now let's see the behavior. We are uploading the code based on the hex file in the desktop, and okay. Okay. Now if you see, based on the value that they had taken, they are showing the code. Okay. 31 and 34. 7.3. Okay, in 7.31 they are asking you to convert this to decimal. Like what number will it be? And display the digit on port B, C, and D. Now these are the outputs. They will be displaying the input that is given in the form. So they have taken all of the, which means all of them need to show the same. So let's run it, upload the hex code, stop 31, and okay. So you can see based on it, the LEDs have turned on. Now moving on to the last one. It's 34, and in 34 they're asking you to bring a byte of data serially 1 bit at a time on port C pin 3. The LSB should come in first. So what is happening is that they are taking a character X in which they are storing, or which they are setting to 0. Now they are setting to the serial pin to 1, like it is set pin. SCR pin is basically acting as input. The loop will run for 8 times exactly, or you can say 7 times based on whether you are counting 0 or not, and it will shift the register to 1 bit. Let's see the behavior here. We will be uploading the code 7.34x5 and start. Okay, let's troubleshoot it later. And this was the overall view of the codes that we use and how do we simulate them in the Proteus as well. Thank you.